There we go. So yeah, I'm going to simply go over a little bit of this eye tracking projects a little bit. So this is the whiteboard stuff. So overall, what we want to do is using the eye tracking system to analyze and probably monitor a person's or people's mental condition because the pupil rate, okay, so and the pupil movement can best demonstrate a person's mental condition. So that's something here. A very easy structure is we can simply use something really, really simple and really, really fun to start with these projects. Firstly, I guess this kind of game, we saw that already. So for instance, um, it dropped emojis or anything else, and you tap it, you collect the coins, whatever the stuff. And some people may miss this one, right? May miss that. And eventually, we're using the eye tracking, the real eye tracking to control the cursor. So therefore, people can move their pupils and will head to capture this. So this will basically um first of all, it will free people's hands, right? And the second of all, it can analyze people's reaction rate, like the eyes reaction. Third of all, it also adds more contributions to our community because I saw some patients, they have difficulties in moving their hands. So therefore, they can use eye tracker tracking to make a command, such as open a website, um, or do some thing that can replace a tab, right? So stuff here. Okay, so this is the idea. So E represents the number of emojis, and L is the levels, T is the time at each levels. These are very important things, which is the successful rate. So X represents the number of emojis or whatever the things collected, N is the number of the total. And then we also have a weighted. That simply means if user can, um, for instance, if user can collect all the emoji within the time, right? So that simply means the guy is doing it faster, right? Doing it faster. Okay. Whatever. No miss. Basically, it's no miss. All right, something like that. Um, and then we use a delta t represent the difference between used time and remaining time, right? Okay. So then we can use this to train people's like the how to say the reaction, and then probably can either send this results data to medical center to do some other stuff here, basically that. Example number one is the level one. Suppose there are three emojis and the time is 3 seconds, and the successful rate is basically the number of emoji collected over the total number of emoji. So if I collected two emojis, then simply means it is a 2/3. That is, well, the number, right? And a weighted is basically suppose total time of 3 seconds. If I collected in 1 second, one, two, three, right? So then, well, that simply means I did a good job, right? Okay. Okay. And the how do we implement it? Pretty straightforward. So firstly, we randomly position all the emojis and into a stack, right? One, two, three. The stack can be an array, and the time is always going to be less than equals to the number of emoji. I guess it makes sense, right? Okay. And drop EI with a random this time interval. So we don't want, that simply means that we scatter it, right? We scattered all the emojis either evenly or unevenly. And then this is basically the visual demonstration here. Over right here is a success and then it's a failure, all right, below the bar. And then we convert it into a statistical model here, can be a normal distribution or a binomial distribution. A binomial distribution basically is successful and a failure. And then we can use the PDF probability density function to accumulate the results, something like that. So overall, this is basically a end-to-end researching process here. So something like that. Okay. But right now I want Jonathan, maybe do you want to introduce yourself a little bit? Um,
Yeah, sure. So I mainly worked with Alex throughout high school and a little bit into freshman year of college, but right now I'm a rising junior at the University of Rochester. I study computational bio. I'm looking to do an apply to medical school. Um, I've had a good amount of experience in like app dev, which has been pretty helpful. I've worked on a few like machine learning projects as well, doing some research at WashU and also Memorial Sloan Kettering, which is a cancer center. Um, and yeah, happy to join the team.
Sounds good. Yeah, Jonathan's been working with me, yeah, since high school. So College Capital, is one of his great works. It helps millions of students to apply college, and of course, it supports Jonathan to go to top school as well. Um, and Jonathan, do you want to probably maybe share a little bit of your portfolio? Like, what do you have been doing? Like, any research or actual software at your current institutions? Just some sample works. Just you can share our screen to give us a quick overall review. Yes.
I feel like most of my work, because it's dealing with like patient data, I don't have access to like the code or my project specifically because after you leave an institution, you lose access to all the data, but I can kind of like let's see if I can share with you something. I have like a recent publication looking at like how to prompt large language models to let's see. I have like a publication looking at how to prompt large language models to extract data from unstructured healthcare records. I think that's been pretty interesting so far, just working with like how to better structure healthcare information for further research. And I feel like that's been pretty interesting. So this is more of just like statistical analysis work. In terms of like SWE, I haven't had the most opportunity to work with um, that as well, but at most recently, like over the summer, I was using Python and Bash to create like pipelines to analyze cancer mutations as well. And yeah, that's basically it.
Okay, that sounds good. Oh, and by the way, we have lots of Alex. All right. Oh, by the way, so did you study any statistics or mathematics currently?
Yeah, I took a few intro statistic classes, so this is pretty familiar to me.
Okay. I see that. Okay, so normal distribution, binomial distribution, continuous, discrete, and so those sounds familiar, right? Those are stuff.
Yeah,
Okay, good. All right. And the variance, standard deviation, makes sense, right?
yeah.
Okay, good. All right. So this is, do you have any um experience in like vision or mental related, such as neuro, how would like eye tracking or something like that.
Yeah, I think. that's not something I've looked specifically at, but I've been involved in like a neurosurgery lab at Rochester. So I think I have some familiarity with that as well.
Okay. Okay, makes sense. Another question is if if okay, if you have the eye tracking system here, right, can
Right.
track what would possibly you can do with it to connect to healthcare and then well disease or disorder treatment stuff, something
Right.
like that. Yeah.
Um, I can definitely I can definitely do some research on that. I feel like it's very applicable. Like there's studies that show that eye tracking is related to like autism or like ADHD, or it's also a important metric after like rehabilitation from surgery. Because how smooth your eyes move across a screen or something can be indicative of like is your neurology processes working well. They can also like by extension, they're also a factor of like how well that you can pay attention to something. Um, so I definitely do think it's pretty applicable and that we can justify it if we want to tie it into like health care or health conditions.
Okay, that makes sense. Okay, good. So basically, this project will be using iOS and maybe Android in the future, but firstly, iOS first and maybe web first, because iOS is more reliable. So yeah. Uh, have you been using Swift throughout the course at your college, the iOS development?
No, I have not. I don't think they
Okay.
offer any like app dev classes.
Mm, okay. So mostly you working with you're using Python and the Bash, right? You mentioned before.
Yeah, Python, R, Bash, these are very much research based.
Okay. That makes sense. That makes sense. Okay. So I guess yeah, pretty good. So you have a strong researching background and medical related and a good sense of vision implementation, eye tracking stuff, I guess. Pretty good. Yeah, good to see you, Jonathan. Oh, and by the way, are you back to you're back to California, right?
Yeah, I just got back 2 days ago, and then I'm here for around a month or so.
Okay. All right. So I guess I'm at Irvine as well. I mean, if you have time, you can drop by at my office and yeah, we just maybe grab some coffee and we talk about this a bit furthermore. All right. Sounds
Yeah,
good.
that sounds
Okay,
good.
good. Thank you for your time, and then I'll be see you next time. All right.
Yeah,
Okay.
sure.
Bye, Jonathan. Yeah.
How about I'll see you.
Bye. See you.
Bye.
All right, Alex. So, uh, oh, wait a second. Wait a second.